Okay then, so what you've just seen are some rather nice looking patterns, and they're what we call Lissajous figures or Bowditch curves. And they're what happens when you get a superposition of two different waves acting perpendicularly to each other. So in plain English, that's two waves oscillating up and down. One's going that direction, the other's at 90 degrees to it. And when they interact with one another, you get interference, which can either be constructive, where it amplifies, or destructive, where it crosses it down. Now with these waves, if the ratio between them is rational, so if it forms a whole number, then you get a nice closed curve and some of the nice patterns we saw before. If it's not, you get what's called a space filling curve, and that's essentially chaotic. It'll eventually fill up all the sort of range of the area that it's covering. Now, musical intervals, as you may have noticed if you watched my previous video, are rational. So when we play nice harmonic notes, or harmonically related notes, what we get are nice patterns, and so that's what you're seeing there. And so what I'll show you now is a demonstration of just one note and then what happens when we add some harmonically related notes to it. And obviously what I'm dealing with here is a 12-note sort of equal tempered instrument. So all the notes will be vaguely harmonically related, but because the 12 notes don't fit nicely into a single octave, they'll all be slightly off as well, so it won't be the perfect curves. In the next video I'll show you what happens if you get a perfect ratio and give you a bit more of a demonstration of how Lissajous curves are produced. Okay, so what I've got here is a little analog synthesizer, and what that's doing is giving us what's basically a pure tone, give or take. It's not quite pure, but you'll see if I play a single note, then we get a very simple pattern. And because we've got a sort of oscillating rubber sheet here, what's happening is you're getting sort of waves bouncing around and they're constructively interfering to give us a nice circle. Now, if I add another frequency to that, then what we'll start to get are Lissajous patterns. And what I'll do is I'll add a nice harmonic one, so our perfect fifth. And you can see that produces a shape that's very stable. It sort of moves a little bit, it processes a little bit because it's not quite perfect, and obviously our system's not perfect either. But it gives you an idea of what happens when you have a nice harmonic relation. On the other hand, if I do keys that are practically out of tune with each other, you get a very chaotic pattern. And I say that will eventually fill all space. Now it's very interesting. What you can do is you can add more and more tones. So if I add, for example, a major third, that's a nice harmonic relationship, but because they're a little bit out of tune with each other, thanks to our 12-note scale, it then processes round a little. But I can add all those together with our perfect fifth. And you see we get a very complicated but mostly closed shape. And if we start to make a little discordance, so if I do a minor chord, you can see again, just that little bit of discordance in there makes it much more chaotic. So Lissajous patterns produce nice closed curves when we have our rational ratio between the two wave frequencies. And that's what we get when we have a harmonic interval, say like the major fifth or any others.